Hello everyone. Let us discuss about the topic signal flow graph model under unit 1 of control systems. The main objective of this video lecture is to introduce the components and their representation of a signal flow graph model. Signal flow graph is a graphical representation of a control system. So this flow graph is developed by S.J. Mason. The signal flow graph is a diagram that represents a set of simultaneous algebraic equations. The signal flow graph depicts the flow of signal from one point of a system to another and it gives relationship between the variables of linear algebraic equation. In the signal flow graph, signal flows in one direction. The direction of the signal is indicated by an arrow. The signal flow graph approach and the block diagram approach yields the same information. So some of the advantages for signal flow graphs are overflow system gain is computed yearly using Mason's gain formula and simpler than block diagram reduction technique. So next I will explain some of the terms used in the signal flow graph. So first one is a node. So it is a represents system variable which is equal to sum of all incoming signal at node. Outgoing signals from one node do not affect the value of the node variable. So this is one of the node here, R and E and C. These are all the nodes. So branch. The signal travels along a branch from one node to another node in the direction indicated by the branch arrow and in the process gets multiplied by the gain. So are transmittance of the branch. Okay. So next input node or source. So input node is here. This is R as an input node. So the node with only outgoing branches. Here this is R is an example. Here is R is an input node. Output node or otherwise called a sink. This node only incoming branches. Example C is the output for node here. So path. The travels of connected branches in the direction of the branch arrows such that no node travels more than once. That is a path. Next, forward path. The path from one input node to output node. Example, here this is the input node here. The output node is this one. So forward path is this one. REC is the forward path. In this diagram, REC. Again C. Okay, REC same though. So the loop. Next one is a path which originates and terminates at the same node. Example, ECBE. Sorry, ECE. There is one of the ECB also is one of the node. So that ECBC is one complete loop. Next, non-touching loop. Loops are said to be non-touching if they do not possess any common node. So next, forward path gain. The product of the branch gain encountered in traversing the loop. Example, forward path REC, the gain for that one is G. Okay. So next one is a loop gain. The product of branch gain encountered in traversing the loop for the loop CBE. The gain is minus GH. Next, the node or summing point. This one. So with the reference to the signal flow graph, the node variable x1 is expressed as, so what is the signal here flowing is A31, here A41, A21, A15, A16. So these are all the signals. These three signals are incoming. These two signals are outgoing signal. So what is the expression for x1 is A21 into x2 A31 into X3, A41 into X4. So you can add all the incoming signals, that is your X1. So next one is a node as a transmitting point, that means outgoing. The node variable is transmitted through all the branches outgoing from the node. So here this is a say example X5 is nothing but A15 into X1. Similarly X6 is the A16 into X1. So next, how to construct the signal flow graph. Consider a system represented by algebraic equation. So this is the first equation. X2 is equal to A12 X1 plus A32 X3 plus A42 X4 plus A52 X5. This is the first equation. Similarly, for second equation is X3 is equal to A23 X2. A4 is A34 X3 plus A44 X4. X5 is A35 and X3 plus A45 X4, where X1 is the input variables and X5 is the output variable. These are nodes. What are all the nodes here? X1, X2, X3, X4, X5. So these are all the nodes. First you note the nodes. So first equation, X2 is equal to A12 X1 plus A32 X3 plus A42 X4 plus A52 X3. So how will you express in signal flow graph for this equation means this one. So here X2 you put it here. So X2 is nothing but A12 X1. Okay, this is a node A12 X1. You can connect like this, and then next one is a X3. X3 length you can draw the A32 for this direction, and similarly X4 A42 and then X5 to A52. Next second equation, X3 is equal to A23 into X2. So X3 is equal to A23 into X2. Next one, X4 is equal to A34 X3 plus A44 X4. So X4, you can write X4. X4 is nothing but A34 X3. You can draw like this, and then in the loop is itself. So A44 X4. Next one is the X5 is equal to A35 X3 plus A45 X4. So what is the X5? This is X5. So X5 is X3 into A35 and then A45 you can draw like this. Next, complete signal flow graph is this one. So you can add all the signal flow graphs in one. So this is our complete signal flow graph for a given algebraic equations. So next one is the Mason's gain formula. The relationship between the input and output variable of a signal flow graph is given by the net gain between the input and output node, and it is known as overall gain of the system. The Mason's gain formula is T is equal to 1 by delta summation k pk delta k, where pk is the path gain of the kth forward path, delta is nothing but determinant of the graph, so that is 1 minus sum of loop gains of individual loops plus sum of gain product of all possible combination of two non-touching loops minus sum of gain product of all possible combination of three non-touching loop, etc. So this is a delta. Okay. So next you substitute delta is equal to 1 minus summation m pm1 plus summation m pm2 minus summation m pm3, like this. The sign will be alternated. So where pm is a gain product of mth combination of or non-touching loops. So delta k is the value for the part of the graph not touching the kth forward path, where T is the overall gain of the system. The first problem, to find the transfer function of the given signal flow graph. This is the flow graph. The first step, you can find the forward path with the gain. So here, look at this diagram here, having two forward path. So one is the this one. Forward path means input and then go to the output. Forward direction only. So x1, x2, x3, x4, x5 is the first forward path. So you can draw the first forward path along with the signals. So and then similarly second forward path is x1, x2, and then this will be going to xy. So missing the x4. This is the second forward path. You write the product, that is gain of that value. So P1 is equal to A12, A23, A34, A45, and then P2 is A12, A23, A35. Next, you can find the individual loop gains. So what are all the individual loop gains here is having 5 loops. Okay, so first loop P11 is equal to this loop is no you know what is a loop. So what is a loop means the originating starting and terminating the same point. So this is the loop for the given problem, one of the loop, and another loop is this one, x2, x3, x4 and then x2, and then the x4 is the one of the loop. Next one is the x2, x3, x4, x5, x2. Next loop is this one. So x2, x3 and then x5 and then x2. Okay, these are all the 5 loops. So accordingly you can write the gain of that loops. P11 is equal to A23, A32, and then P21 is A23, A34, A42, and P31 is A44, and P41 is A23, A34, A45 and A52. Next one is A51 is equal to A23, A35, A52. Okay, so these are all the individual loop gains. Next step, you can find the combination of two non-touching loops. Here the non-touching loops is only 2. So that P12 is equal to, non-touching means the nodes which are not touched with another loops. So that this is one of the non-touching, this is another non-touching. So this is what is the P12 is nothing but P11 into P41. You can multiply that product, the gain product, A23, A32 and A44 as the gain product for the first non-touching loop, and second non-touching loop is P51 and P31. Okay, so this is a gain for that one. You can multiply both P51 and P31. So next one is you can find the delta value. So delta is nothing but 1 minus the individual loop plus the 2 non-touching loops, and then minus the 3 non-touching, the gain product of 3 non-touching. In this problem, the 3 non-touching loops are not presented. So that only you have delta is equal to 1 minus the corresponding gain values. You have to write it here. So P11 is equal to A23, A31, P21 like this, P31, P41, P51. After that you can write the gain product of 2 non-touching loops. Next one, the first forward path is in touch with all the loops. So no combinations of 3 non-touching loops. the 4 non-touching loops, etc. Next, find the first forward path is in touch with all the loops. That is the delta 1 is equal to 1. The first forward path means this when the first forward path is the entire nodes are presented, so that there is no part of the graph which is non-touching with the first forward path, so that the delta 1 is equal to 1. So next, for second forward path, only one loop is there, that is a non-touching loop. So that 1 minus that gain product, that is a delta 2. 1 minus A44 is a delta 2. So here the forward path is only 2. So depending upon the forward path, you can write the Mason's gain formula. So T is equal to 1 by delta, summation K is equal to 2 Pk delta K. So you can substitute the K value into this equation and expand it. T is equal to P1 delta 1 plus P2 delta 2 divided by delta. You know the values of P1 delta 1, P2 delta 2 and then delta, just substitute. There is a final transfer function for the given signal flow graph model, that is x5 by x1. So that is equal to 1 by 1 A12, A23, A34, A45 plus A12, A23, A35 into 1 minus A44 divided by 1 minus A23, A32 minus A23, A34, A42 minus A23, A34, A45, A52 plus A23, A32, A44 plus A23, A35, A52 and A44. This is the overall transfer function for the given signal flow graph model. Next, the second problem, that is a find the overall transfer function or gain of the given signal flow graph C of S by R of S. So in this problem, look at this signal flow graph. In this problem, having only one forward path, so K value is equal to 1, so that you can draw the forward path gain along with the diagram, so that the forward path gain is P1 is equal to G1, G2, G3, G4. So next one is the individual loops. Here the individual loops are 3 individual loops for this given problem. So first loop is, so this is the first loop, 3, 4, 5, 3 is the first loop. So you can draw the separate individual loop and then corresponding gain product. The gain product is minus, because this is H2 is a minus, so that G1, G3, H2 is a gain product of first individual loop. Second loop, this one, the 4, 5, 6, 4 is the second individual loop. You can draw that one and then you noted the gain product for that one. So that minus G3, G4, H1. The next another, the final loop is, individual loop is 2, 3, 4, 5, 6, 2. This is another loop. So you can draw that one and then you noted that corresponding gain product. So minus of G1, G2, G3, G4. So these are all the 3 individual loops. Next, the 2 non-touching loops. Here no 2 non-touching loops are there. So that will be 0. So delta is equal to 1 minus P11 plus P21 plus P31. So you just substitute these values. So here no part of the graph is non-touching with the forward path. So delta, so that the delta 1 is equal to 1. So now you can substitute Mason's gain formula. You know all the values, delta and delta 1, P1. So just substitute, because here the K1 is, there is a number of forward path is only 1. So depending upon this, you can write the Mason's gain formula. So that T is equal to P1 delta 1 by delta. Just substitute the P1 value and delta 1 value, delta value. So that is a final transfer function for the given signal flow graph. So C of S by R of S is equal to G1, G2, G3, G4 divided by 1 plus G3, G4, H1 plus G2, G3, H2 plus G1, G2, G3, G4. This is a transfer function for the given signal flow graph. So next one is that is a conversion from block diagram to signal flow graph for the given block diagram model. So find the C of S by R of S. In this diagram, first you can convert the nodes are assigned at input output at every summing point and branch point. First you are giving the node values. So node na you can give the node. First input node is 1. This is the input node. You put the node number is 1. Output is also another node. And a summing point, a branch points also, yeah, every nodes. So, okay, so this is a summing point, you put it 2, this is a branch point 3, this is another branch point 4, again this is a summer, you can put it 5, this is the output 6. So, having 6 nodes are presented, we can draw the equivalent signal flow graph. So, this is a 6 nodes, 1, 2, 3, 4, 5, 6 nodes. So having the first 1, 2, 3 corresponding, you can write the gains. So after that, what is the loops are presented here? The loops for this one is A3, there is a node 3 to 5 is G3, and then similarly node 4 to 2 is the feedback minus H. Okay, so next you put that one here 3 to 5 is a minus G3 and 3 to 2 minus H. So here in this diagram, look at the signal flow graph. Only 2 forward path. One is this one, the entire 1 to 1, 2, 3, 4, 5 to 6 is a one for first forward path. Another forward path is 1, 2, 3 and then 5, 6. This is the second forward path. The corresponding gains are P1 is equal to G1, G2 and then P2 is equal to minus G3. Okay. So next, not touching loops, individual loop. First, next you can find the individual loops. So individual loop is only 1. So that P11 is equal to minus of G1H. Okay, minus of G1H is the individual loop gain product. Next one is the 2 non-touching loops is not there in this problem. So that P12 is equal to 0. So now, what is the delta? Delta is nothing but 1 minus the individual gain plus the 2 non-touching loops and then minus 3 non-touching loops if it is possible for this problem, means you can write like this. Here the 2 non-touching loops are not there, so that only for 1 minus P11. So 1 minus of H-G1 is equal to 1 plus G1H. So the first forward path, next you can find, first you can find the delta. So and then you can find the delta 1. So the first forward path of individual loop is not touching with that. So that delta 1 is equal to 1. So this is the forward path, the entire forward path. So that since there is no touching path, so that delta 1 is equal to 1. So next loop, the second forward path is also in touch with the loop. So that as a delta 2 is also equal to 1. So in this problem here, the forward path is k is equal to 2. So that the Mason's gain formula is T is equal to 1 by delta summation k is equal to 2 pk delta k. You expand this gain formula according to that gain value k, that is forward path gain value 2. So that the formula will becomes P1 delta 1 plus P2 delta 2 divided by delta. So that is a transfer function for the given system. So C of S by R of S is equal to you substitute this P1 and delta 1. G1, G2, 1 plus minus of G3, delta 2 again 1. Okay, 1 divided by delta is 1 plus G1H. Can simplify this. The final answer is G1, G2 minus G3 divided by 1 plus G1H. So this is a final transfer function for the given block diagram model. These are the references I referred for preparing this video lecture. Thank you for watching this video.